Hi, everyone. Thank you for joining today's webinar, Financial Data Pipelines at Quantopian. Today's speaker is one of Quantopian's site reliability engineers, James Meickle.
All right, thank you for the introduction. Welcome, everyone. First time doing one of these webinars, so I'm really glad you're here for it. I'm going to be talking today about how we actually run our own internal data pipelines at Quantopian. And why am I giving this presentation? Well, I'm actually on Quantopian's site reliability engineering team. That's the team that keeps all of the website, all of the data sources up and running. And that job title, Site Reliability Engineer, came out of Google. It was a program that they started there that's been exported to a lot of other companies. I've been doing this for a while before I came to Quantopian, so working with various kinds of data like processing MRI scans at the Harvard Center for Brain Science. And I just want to make clear that I am coming to this from a perspective of being a site reliability engineer. So this was not something where I already knew a lot about the market before working at Quantopian. So that's an important disclaimer. Also, any opinions I express are my own, not Quantopian's. Most importantly, this presentation is not investment advice. And we do actually take that sort of regulation very seriously at Quantopian. I don't know if you saw this in the news a little while ago. We both have external regulations and internal policies on what we say. So I will be talking some of what Quantopian does as a business, but some things like our performance numbers, we're not going to be able to tell you, so don't ask questions about those. All right, so let's talk a little bit about what data means in the context of Quantopian. And because you are coming in through this webinar, I'm assuming you know a little bit more than the normal audience for this presentation about what we do. But just as a recap, we're a crowdsourced quantitative investment firm with over 200,000 users in the community from more than 190 countries. So we provide resources so that you can learn how to write financial algorithms in Python, trade them on the market. We provide allocations. So you can see the numbers there, what it was the last time that I checked, of over 50 million as a peak allocation to a single algorithm. So needless to say, we're not a traditional financial institution. We approach things a little more differently, more of a startup feel, certainly around the office. Now, we're a small company, but we're succeeding at what we do. And we recently entered into a partnership with FactSet, one of the largest financial data providers in the world. If you've seen the posts on the community about the types of new data that are available, like the new international equities, that's coming directly out of this partnership. But that also means that we're ingesting a lot more data than we previously were, and it means that we have more of an emphasis on making that data reliable so that it's always available in the platform to all of our end users. You might have also seen the feature announcement for Quantopian's self-serve data. So you can always come in and write your own algorithms in Quantopian, but a somewhat newer feature is that you can also bring your own data along with those algorithms. So if you have some algorithm that depends on some data source that you're providing, you can still run it on the platform. The upshot of this is now it's not even just Quantopian employees adding new data sets, it's members of the community like you. So that's actually two major new initiatives that are increasing the types of data that we're ingesting, the size of that data. And that falls on the SRE team, ultimately, to be responsible for the performance of the ingestion and making sure the data is reliably available. Just as a recap, since I know not everyone is coming to this presentation as an engineer, the site reliability engineering team is a little different from some of the other programming teams at Quantopian. They tend to work on specific features, whereas we support all of the different projects that they're working on. So we use Amazon Web Services. We support all of that infrastructure. We help with monitoring and logging. We help with architectural decisions for these services and making sure that all the building and testing and deploying of our software goes as anticipated. Now, within the SRE team, we have 6 SREs at the moment. All of those SREs get attached to a particular team, and the team that I'm attached to is the Black team. We're the team that's responsible for a lot of the data infrastructure and a lot of the fund adjacent programming that goes into making Quantopian work. So things like ingesting data that's used by algorithms that we trade on the stock market, or productizing data science projects. That's the kind of work that the Black team typically works on. When we say data, you're probably pretty familiar with what we call our community data sources. So the things that we might do to make that data available in the community, we need to ingest it from vendors, we need to reconcile it, clean it, look for errors in that data, which often comes in from community feedback, and then address those errors and fix it day over day. As well as the portfolio risk model. If you've been using that feature on Quantopian, that's something that we're producing using our own data. But also, we have a lot of internal data sources. That could be user analytics data, who's been visiting the website, algorithm performance, risk management decisions, reporting for compliance purposes. When you're trading money yourself, you need to make a lot of decisions there. And actually, that's one of the reasons why the allocation mechanism is really nice, because that means if you get an allocation, you don't have to worry about a lot of that yourself. Of course, when you increase the amount of data that you have, you also increase the amount of problems. And it was towards the end of last year, so I guess about a year now that I've been working on this, of improving what we call our ETL pipelines. ETL stands for extract, transform, load. It's like an older acronym, but basically that means any kind of data processing. So I was responsible for the initial research on this, as well as a lot of the implementation that we've done as a company since. And what I had to do first was scope out what our existing problems were. So one problem is that we have a need for high reliability. With a lot of industry data processing, it does matter that you eventually get the correct result, but it doesn't necessarily matter that you get it done immediately. For instance, if you take visitors to your website, you might need to produce a report every month showing those results. If you need to rerun a report, that's not ideal, but you can probably do it. The fact that Quantopian makes trading decisions based off of data and based off of algorithm performance means that we need to be highly reliable day over day. It's sort of like an immutable record. Once you place a trade, you can't go back on it. There's already been money at stake there. So it's really important that we're always available to trade and that we always have the correct data to make those trading decisions based off of. Because of that, we have to worry about unreliable data. And when I say unreliable data, there's two primary things that I'm talking about here. One of them is that the data source might just not have good uptime. It could be a small service that gets overwhelmed occasionally. It could be a larger service that's doing some migration and is temporarily unavailable. We have some data that we do need to have available every night, and we do have to work with external vendors to get most of that data. So a lot of that you don't necessarily see on the platform, but that's what's happening behind the scenes, is we're working through all of these data problems. The other class of those data problems we might run into is where the data is made available to us, but it's wrong. And sometimes that can be really hard to detect, and it can certainly be impactful. Just to give an example as something that could happen, we track whether a company is up for acquisition right now. So when a potential acquisition or merger is announced in the news, we'll actually have a record of that. And sometimes what will happen is that the M&A process gets noted properly, that there is an M&A in progress, but it doesn't get noted properly what side is doing the acquiring, and they reverse those two. So we'll say some very small company is acquiring a huge company. So that's not something we could correctly base decisions off of. So that's the kind of data quality fix that we need to put into place, potentially overnight, because that's when some of this data is arriving. So that's what we have to do to get it ready to trade the next day. Now, if you're not a programmer yourself, or if you're not used to infrastructural programming, a lot of that kind of nightly scheduling gets done through a program called cron. Cron is a really old program. I think it's older than I am, actually. And all it does is schedule things to run at particular times of day. So if you think of the market, right, you might think, well, it opens at the same time, it closes at the same time. And that's usually true, but it's not always true. So sometimes the market has half days, or it closes early due to an emergency, or there's a regularly scheduled holiday, but the date of that holiday moves each year. And cron is a very simple scheduling tool. It's what we initially used because it's very easy to set up at first. Well, once you start having dozens or hundreds of these cron jobs in place, the odds that one of them is going to fail in an unexpected way starts to really increase. So there's a lot of brittleness there if you only base things on static start times instead of really tracking the data dependencies. Because in a lot of cases, you don't just need to run one job, you need to run a sequence of jobs, moving data from one place to another, applying transformations to it, merging them into one unified data set. So we wound up at a place where we had a lot of cron tabs, and we were able to keep everything running on the website with those cron tabs. But it required a lot more manual intervention than we wanted. If something failed overnight, it could cause a chain reaction and cause several other failures, and we would actually have to address all of those manually. So it was taking a lot of toll on our team. Now, one other problem, when you have a lot of those cron tabs, I mentioned that the stock market stock markets don't trade on entirely regular schedules, so they're not actually a good fit for cron. And that meant that we had a lot of special cases, like a job would run on Thanksgiving, but it would check an internal calendar. And even though the job ran, it wouldn't do anything on that day. And that meant if the calendar was slightly wrong in some data set, that you would get very confusing results. Basically, all of our services had some part of the scheduling logic embedded directly in that service. And that meant that it was really hard to get an overall view of what tasks were firing, why they thought they should fire that day, what things they were blocking downstream from them. And if you think about this from the perspective of the SRE team, none of us are coming into this being finance experts. We're operations experts. We know a lot about computers, but we don't know each one of these data sets. We don't know each one of these vendors. So if we get paged at 2 in the morning and we have to make a decision, we need to know really quickly what we actually have to fix, who else we might have to wake up. So the idea that we had all these unstructured forms of data, we needed to actually impose some structure on that to be able to do our job better. And of course, all of this eventually had the cost of increasing the bottleneck on SRE. We do a lot of things here at Quantopian. There's a lot of requests for our services. So if we spend a lot of time babysitting these cron jobs and making sure they're running successfully, it does provide the reliability that we need, but it also prevents us from doing other things that we'd rather be doing, like helping get software deployed. So it was really easy to say we wanted to fix our data pipelines, but this wasn't the kind of problem that we could fix one cron tab at a time. We had to approach this in a more systematic way and decide to make a strategic investment. Before you can make any kind of strategic investment, though, you need to understand what your goals are as a business. So that actually informed how we went about tool selection. One of the primary goals was reliability, especially for the parts of our infrastructure that are actually trading real money. We're accountable to our investors, so that's really important to us. We were, again, achieving that reliability, but this was something where we were getting paged very frequently about data problems, and it wasn't something where you could just size up a database or basically put more money into solving this problem. We needed to take a step back and understand how to simplify our environment because the human cost was too high. It was getting in the way of any further growth. We wanted to make sure that observability was a goal. When we make decisions for who's going to get an allocation, that's all based on data and it's based on process. We don't make arbitrary decisions. We need to understand how to reproduce results. And it's very hard to do that if you don't know why a certain data set was ingested, when it happened. So it was taking longer than we wanted to answer questions like that. So we decided that we also needed a tool that was capable of understanding the overall flow of data through our systems to answer questions. We also needed more ability to iterate quickly on new data projects. We embarked on this before we actually got that FactSet partnership in place, but we knew that that was something we were going to be working on. We were going to be expanding to international markets, to self-serve data, and our community was going to continue growing in size. So we always want to be able to release things to you faster. And all of our projects essentially required a lot of SRE time to set up initially. So at the same time that we're bottlenecked on helping these cron jobs run successfully, that was slowing us down in releasing new features. We needed a platform that didn't just make it easier to maintain cron jobs, but also made it easier to be a little more self-service so that you wouldn't need to have SREs even help you set up a cron job. It would be something you could do yourself. Well, our data problems are unique, just like everyone else's, because the reality is that almost anyone in any industry working with data, which is all industries nowadays, they all face these kinds of problems. Certainly the finance industry does, but this also applies to people in marketing and transportation. They're all working with complex data sets. They're working on integrating all of that data. That's a lot of what you're doing as a user of Quantopian, is trying to find alpha by bringing various data sets together. So if you've heard of the term DevOps before, it's bridging the gap between development teams and operations teams. That's essentially a lot of what I'm doing in my day-to-day job. When we went to tool selection, there were a few differences that I wanted to emphasize that helped us make our choice. Because while most companies have this set of problems, Quantopian does have some attributes that set us apart in choosing a solution, basically. One of them is that we really believe in democratization as a company. The same way that we make all of our tutorials, our IDE, available to you, well, we want to do that internally as well. We want one developer working on one feature to be able to see what any other developer is doing, to contribute to it, to understand why that code was merged. And we're really code heavy at Quantopian. If we do a weekly meeting where we talk about our business strategy, and most of the slides from there are not coming from PowerPoint. They're just screenshots of Jupyter notebooks. They were actually generated with Python. So we really wanted this to be code-centric, to have a code as the unit of that democracy and of sharing. We didn't want this something where you needed to log into a machine and run a command. We didn't want this something where you have to spend a full day setting your local environment up. And one other thing that I wanted to mention is the types of data that we have are a little non-traditional. Finance has its own sort of model of data. And while you might think of the data that you're processing as being like a lot of data, compared to something like visitor logs on a website, it's actually like a fairly small data set. It's a small data set with a lot of complexity, as opposed to a huge data set where each individual line is almost worthless. That meant that we're not talking about existing big data solutions like Hadoop or Spark. Or likewise, because most financial data is actually arriving day over day, it's not streaming data. It's not arriving constantly. So we didn't use a streaming solution like Kafka. We were also somewhat constrained by wanting to run this ourselves. So there are, of course, vendors who will sell you any sort of solution that you want, but we take your algorithm source code very seriously. We don't want to outsource things to a vendor we don't have control over, so we decided we wanted something we could run in-house. So as we started to research this, one of the first decisions we came to is that we actually didn't want to have an ETL system in place. We wanted instead a more general workflow management engine. And the reason is that not everything that we do is based on moving files around or loading things into databases. That's a large part of this data processing. But as an example, every time we produce new data and make it available, we need to go change the servers that are running on the backtest environment. It's what you see when you actually run a backtest on Quantopian. So if we want to make that new backtest data available, we need to take an action based on that data to restart a number of servers. So we didn't want something that assumed that every task we ran was something to do with data. Sometimes we need to take actions as a result of that data becoming available. So again, not an ETL system. The other major decision that we made is that we have a lot of data dependencies at Quantopian, so we wanted to be able to express these tasks as a directed acyclic graph. What that means is a series of nodes that have pointers that only go in one direction downstream in that graph. So you can never have a cycle or a loop. You can run the same graph day over day, but within each day, it's all flowing downstream. So that's what that looks like in our actual system that we're running, Apache Airflow, to have a DAG. You can see that there's a series of tasks. It chooses one of those branches in this case and follows it all the way to the end. Another important constraint on our workflows was we needed something that could encode a lot of arbitrary business logic. Like I mentioned, cron is a very simple scheduler, whereas finance is a legacy industry. There's weird schedules and rules and concepts. We're really running into this a lot as we add international markets. Every market trades not only in a different time zone, but on a different schedule, both when it starts during the day and which holidays it has. Just a random example, Japan actually has a lunch break during the middle of its day. So you can't just use the same assumptions everywhere. It requires a lot of domain-specific knowledge. That's what we're really trying to abstract away so that you don't have to think about that. And as we kind of embarked on this project, we realized we didn't just want to use it for our nightly data loads, not just taking the existing processes that we have and moving it to something more reliable, but also making it easier to experiment with those processes. And it turns out that one of the best ways to have a data system that's easy to experiment on is to make it an immutable or functional data system. What I mean by that is essentially a system that checkpoints data after every transformation. So if you decide to retransform the data in a different way, you have the original data to continue making transformations on. Why would you do something like that? That sounds pretty expensive in terms of storage, right? Well, the idea here is that you never want to make a change to data that's irreversible. You always want to be able to start over again and run the same set of transformations to get the same result. So you want it to be reproducible, and one of the best ways to make it reproducible is to store both all of the steps that you're transforming on the data and all of the steps in between where you actually have a new data artifact. The reason I have this slide up is that's actually the paradigm we used at the Center for Brain Science when we were doing MRI brain scan processing. You always store the intermediate artifacts because it can take a very long time to recompute. So it's sort of like caching those results so you have them available for later. So I could tell you all about the different systems that we looked at, but the reality is that it was a pretty clear choice for us when we went to the tool selection phase. Based on the requirements that I just told you about, the one that made the most sense was to adopt Apache Airflow as our workflow management system. It's a tool for writing workflows or data pipelines as code and then to execute them in a reliable and resilient way. It's perfect for the types of data processing that we do. Now, just a little history on that. It actually came out of Airbnb. So that's where the project initially lived. And it's a Python project. We use a lot of Python here at Quantopian, if you hadn't noticed that. I love it myself. It's my favorite programming language. So I'm really happy to be able to work with it every day. And Airflow is on its 1.10 release. So it's getting pretty close to a 2.0 release. And it's really got some great features. A lot of reasons why we might want to adopt it. One clear reason is just what you get out of the box. Airflow isn't just a library. It's not just some plugin that you add to your scheduling system. It's an entire system out of the box. So it comes with a website, schedule visualization, logging to Amazon S3, security features like lockdown user accounts, integration with monitoring systems. There's a whole laundry list of features that made it really appealing to us as something we could just install from day one and start making progress with. It's also got a lot of tools for helping operators understand why some task is or isn't running, how long it's going to take, how long it's taken historically. Those are all things that can be really useful when you're getting paged overnight and you have to ensure that some process finishes within the next few hours or else you'll miss trading for the day. By capturing all this in a more structured way, rather than having it live across a dozen different servers, instead having it be centralized and version-controlled code, we can produce reports based off of it, like how long tasks have taken historically. So you can see this is how tasks take over a market day, and there was one spike where tasks took several more hours than it normally would. Also, being on the SRE team, a lot of off-the-shelf products like this aren't necessarily ready for real heavy usage or wide-scale adoption. Airflow was really nice because it's inherently a distributed system. It was built out that way. So we could basically just install it in the cloud without having to make heavy modifications. Because one of the goals of a system like this is to reduce the amount of code that you have to write on things that you don't really care about yourself. We care about the jobs that are being scheduled with Airflow. We shouldn't have to care about maintaining an Airflow service itself. One of the features that's been really nice for the team around here is that Airflow is a project that's written in Python, but it's also one that you write Python code to configure. What that means is that our data pipelines are increasingly configured, not just as Python applications, but also scheduled by writing Python. So you write a simple Python expression to say, what days should this run on? What time of day should it run at? That means that you can use the same language both for writing your application and for deploying it. And that's a really nice feature. It means it's very quick for someone to just get ramped up on. So you've all written some code before, and I'm going to go ahead and show you what Airflow code looks like, because this is some real code. There's screenshots from my editor of what the code at Quantopian looks like. Here's an example of an operator in Airflow, which is one of the nodes in that DAG. So it's like one operation that we're performing. In this case, I have an operator that decides whether, based on the current trading calendar, is today a trading holiday. Because we often have some workflows that don't run on trading holidays, whereas some other workflows run every day regardless of trading holidays. In contrast, here's what it looks like to invoke one of those operators. So the DAG code, you write some operator definitions in another file and you import them into this file, which makes them available. And this is actually a real DAG that we run. It's a little silly, but we use a meal ordering service. So we have to know what days we want to order lunch on. So Quantopian, we don't come into the office on days that are stock market holidays. You can't order from this lunch service until it's 9 o'clock in the morning. And we don't order on days that have company meetings because we have catered lunches, right? So this is kind of silly, but that's our business logic for this process. And that's actually how a lot of data pipelines at Quantopian look. We have to run them on very particular days based on logic that's some of our logic, some of the vendor that we're communicating with has their own logic. We have to make decisions like that and be able to quickly encode them and iterate on them. Rather than this being something that an SRE has to log into a server and configure, now this all lives in code and anyone in the company can send in a pull request to modify it. So that's what that looks like. We just get a really simple notification whenever one of these tasks completes. So lunch aside, where do we actually use Airflow in Quantopian? Well, we kind of have three main criteria. And if something meets one of these criteria, it might be in Airflow. If it meets two or three of them, it's definitely going to go into Airflow. One criteria here is whether the task needs to be resilient or distributed. What I mean by that is if there's a failure, does it need to gracefully recover from it automatically? The answer there is usually yes. Sometimes it's no if you have something that runs every hour and it's not a big deal if it misses 2 or 3 iterations. But for all of our nightly data pipelines, yes, they absolutely need to be resilient. Another question that we ask is whether a task produces any downstream data artifacts or consumes any upstream data artifacts. If we have those relationships between data sets, we want to be able to visually track them and to understand them. So that's a good candidate for Airflow if it does have those kinds of dependencies. And the final question, getting back to that idea of democratization, would someone outside of Quantopian's SRE team want to monitor, control, or extend this? Because if we store all of this in code, if we make it easy for anyone in the company to contribute to, people will do that. They'll have unexpected use cases. They'll want to run their own experimental data pipelines, and we can enable them to do that without having to work with our team as closely. So a really good candidate here is Quantopian's nightly data load. This is where we make our core financial data available. So if you used our fundamentals data, that's actually right there, the daily fundamentals. We have to connect to all sorts of different vendors, extract the data, move it from place to place, do verification checks to make sure it seems reasonable. I'll give an example of a failure case that could happen here. If there's some kind of market crash or other unusual spike in activity where there's a lot of trading on that day, like a lot of people selling off, well, it can actually take longer to produce this data because there's literally just more data. It takes more time to iterate over it. And that means that everything runs a little bit later than it normally would because it's taking more time to process more trades. So with our previous cron tab-based system, what would happen is the first cron tab would not fire properly because the initial data it was waiting on was not available. We would have to manually resume that cron tab, but then there might be 5 or 6 more cron tabs deep of times that are now slightly off, and we actually couldn't automatically resume that. So we may still have late arriving data in Airflow, but now instead of firing at specific times, it just fires whenever its dependencies are ready. So as long as you fix that first node that failed, everything downstream will automatically resume. You even get these nice Slack alerts, so it's all integrated with the rest of our systems. Now, because this has been so successful for us, over the past year, we've been moving more and more parts into Airflow. Again, this all lives in code. It can be versioned. It fires through our continuous integration processes. It can be discussed in a pull request. And that means that you don't need to work with SRE at all to get this deployed. It's something that you can do the same way you deploy other software at Quantopian. So this DAG keeps growing over time. In fact, when we added FactSets data to this DAG, it about doubled in size. And we're not even done implementing all of the regions that their data sets can provide us. So you can expect to see this growing over time. And it's got a great service record. Another internal service that's also a data processing system is FileMover, which has actually been the largest source of pages at Quantopian. When I say page, like we actually get woken up overnight about this occasionally. And it's very hard to tell the impact of an outage with this service, because when we're operating as SREs, we know who these vendors are, but we don't necessarily know which files are critical, which files are nice to have. So this cron tab-based system that we actually had as an intern project to try moving as much of that into Airflow as possible. So with someone who is both new to Airflow and new to the finance domain, our SRE intern, Danny, was able to send in 70 GitHub pull requests over the course of the summer to refactor this code to execute in Airflow instead of on the existing instance. So that meant moving notifications into the Airflow system or changing the scheduling logic so that it wasn't based on exact times of day. The upshot of this is we now have a nice graph where we can really easily understand the downstream implications of any type of failure connecting to a particular vendor. And that really helps us make reliable data available to the community. So you can expect that every day data gets updated, even if we internally had that data arrive to us late. We're able to recover before you notice it. So a lot of this work was front-loaded. Really, the only thing stopping us from switching everything to Airflow is we want to be cautious with it and move things over gradually, one job at a time. And that's what this graph is showing. The white spots are where a job wasn't running, and then you can see that we're enabling them at different times. Now, the thing that I've been working on most over the past 2 or 3 months is using Airflow for our internal data science projects. Of course, we care a lot about data at Quantopian, so we're providing data to you. You're doing awesome data science to write algorithms, but we have our internal use cases as well. So we have this cool new project called the Quantopian Alpha Model, which we're just starting to talk about. It's an in-house alpha model that's built on top of ideas from the Quantopian community. So that allows us to incorporate ideas from many more authors into our community than we can do today with the allocation system that we have today. We're actually preparing to trade this in our production environments by the end of the year. And that's something that without Airflow, we would not have been able to do. It's been able to speed up that development. Because essentially what we have here is a data science system that runs the same way that it will in production right from the first day that you start developing it. So you don't have to take a bit of experimental code and figure out how to make it run in production. We've made it so easy to run it the same way that it does in production that you just do that from the start. You can see that this has a lot of waiting on data to be available. It's running this on some real infrastructure with Zipline. And if you ever want to make a change to this, all you have to do is send in a single commit to your Python script, and it'll immediately get redeployed. And you have a nice web interface to rerun this, or it'll just rerun automatically the next day. So this is something that Airflow has enabled for our team that we've never really had the opportunity to do before. If anyone on the webinar today, if you are familiar with Kubernetes, there's been a lot of coverage in it on operations teams. It's a system that was originally designed by Google to make it easy to run Docker containers in the cloud. And actually, Airflow has very good Kubernetes support. Everything that I just showed you on this previous graph, that's all running on our now internal Kubernetes cluster we've been building out over the past year. So being able to use containerized code, again, is a huge efficiency win for us. It's much faster when you're dealing with large, slow Python libraries like pandas, so you don't have to reinstall them every time you deploy. So we essentially now internally have this system where one of our data scientists can write Python code in an algorithm, and then write Python code to schedule that algorithm and run it all day over day with data produced by our real production systems. So to recap here, we've used Airflow at Quantopian for less than a year now. It's got a great service record. It's actually much more stable than the existing systems that it's been replacing, even though it's still something we're burning in. We keep finding new projects to put into Airflow. It was the first service that was able to make use of our new Kubernetes cluster. It's been incredible for our developer productivity, and it's really changed the way that we do data science projects here. In fact, any new data pipeline tasks that we're working on are aiming to be containers scheduled in Kubernetes by Airflow. So really, we want this to be the new standard that we're using internally for any of our data science or data pipeline projects. Airflow is really our data pipeline future going forward. And I really love that. I love working on it. But you don't have to take my word for it. collected what some other folks on the team have said. And these are all just screenshots from our Slack. The reality is that most of the people who work with us love it and are really enthusiastic about how it allows us to deliver better code to you. So I wanted to thank you all for coming to this webinar. I'd be more than happy to answer any questions that you have about either the specific implementation for our data pipelines or our data pipelines in general, because we also have some non-Airflow ones as well. So I see a few questions coming in. Someone had asked during the presentation whether we'd considered Luigi. And actually, we not only just considered Luigi, but we built a project on Luigi, a fairly large one. And in the end, we actually had to take all the Luigi code out of that project. We found it to be so difficult to use in a real-world production environment that it was actually impeding our ability to make changes. So I think Luigi has like a particular use case. It's pretty good for like a local system where all of the files are existing on your machine. But one of the goals of this data pipeline system was to break things into smaller components that communicate effectively. And Luigi did not turn out to be effective for that. I think it's more suited to a local development use case than something like Airflow that's natively a distributed cloud-oriented system. There was another question related to Pachyderm for that. And Pachyderm actually looked pretty cool. That was one of the tools that we evaluated. But again, that looked more suited to like one individual data scientist writing some pipelines locally. Airflow is a little bit better from our perspective as an operator. It comes with a lot of web UI features. It's not tied to any particular vendor. It's very extensible with simple Python code. So even if it may not be the best for a particular machine learning like pipeline goal, overall, it can help to have a more standardized tool. And that's why we ended up choosing Airflow, because of those more operational features. For the ingestion of data from providers, which was another question, we actually have a variety of tools. The file mover service that I mentioned is an in-house service to do a lot of that ingestion. The way that data is typically presented by finance vendors, it's usually FTP or SFTP with the occasional RESTful API for fetching this data. So you typically don't need a very complicated system for ingesting this, but we have built an internal service for managing this. And a lot of what Airflow is doing is orchestrating that internal service. So the file mover service still exists, and we're able to use this ingestion service on a better scheduling platform. And that does relate to a good question that someone asked about keeping copies. Yeah, we actually do keep copies of all the original vendor data in perpetuity. So every time we do an ingestion like this, the first thing that happens is we take the data and move it into an S3 bucket. So the derived artifacts then get produced based off of that. So it's not something where we just load the data into memory and then produce an output artifact. We have discrete steps just for ingesting all the initial data and saving it to a permanent record. That really helps us understand point-in-time data for our services. Like if we had some historical error in one of these data sources, we actually preserve that error. We're not re-ingesting old historical data and potentially overwriting that, which could give false performance indications. There are some questions about streaming data pipelines. I'd say for us, building a streaming data pipeline was not as high a priority because a lot of our most important data sets are not inherently streaming. It is possible to use other streaming services within Airflow. So for instance, Airflow can trigger something with Spark or with Kafka. It can send events to those services. But the Airflow DAGs are actually inherently a batch scheduling system. The way we think of this is the problems we have right now are around batch scheduling, and Airflow addresses those. We would turn to a native streaming system, probably something based on Kafka, if we did actually have enough of a streaming system to warrant a platform like this. So for passing data between Airflow operators, we basically use an S3 backed approach where possible. We have an internal library that helps us with S3 slugs. So for example, the slug will be based off of the version of that data file and the date that it was ingested, as well as the bucket that it was stored in. And the advantage of that is if we use S3 as a unified store of all of our data, some people call it like a data lake system, anything other than Airflow can also access that data in the same way. We haven't used the internal Airflow tools like XCOM for cross operation because there's a lot of quirks associated with those, whereas having data backed in S3 is actually a very well understood data architecture pattern. So we've tried to stick to things that are really off the shelf, easily understood, and quick for other people to jump into. That makes for a healthier data system overall to avoid that kind of complication. There's a question about how do we measure quality of data? That's actually a great question. So that really depends on your domain, right? Just to give an example, when I worked at the Center for Brain Science, we actually had a data quality check that was literally just you look at the MRI scan and you see, does it look like a brain? And it might sound silly, but MRI scanners often produce things that have a lot of artifacts or are really glitchy. Maybe it just didn't take an image, so you've got a blank screen. And it was very hard to programmatically detect that there was something wrong with your data. So for there, a manual data quality check with an operator performing a visual inspection was the right call. It's a lot harder to do that with finance data. It's so complicated and the errors can be more subtle, like something just missing a decimal point so it looks like it made a lot of money suddenly. That sounds silly, but that sort of thing happens all the time. So we have a variety of checks there. That might be checking that known existing tickers have reasonable data values or that they're even present in the data set. Like if we got a report where Google just stopped existing as a company, we would know there was something wrong with that data. That's the way we do futures, for example. Futures contracts are like just a known value so that we know that if a particular contract symbol was missing, it was probably omitted from the data and we need to investigate that. So we actually work those nodes directly into the Airflow diagram. So after a data set is ingested, but before the next step uses that data set, we can run any data quality checks and have them be automatically scheduled. So there was a question about Celery. So I've used Celery before, and I'm not a huge fan of it. Airflow actually does use Celery itself, but Celery doesn't provide a lot of the dependency tracking that you would want. So I think of Celery as more a tool for executing a large number of tasks. It's not actually a data pipeline solution in and of itself. Airflow is a great example of how you can use Celery as a building block for something larger. How much flexibility does Airflow provide for failed tasks partway through pipeline? So Airflow has a lot of operational controls for what should happen if a task fails. It can have automatic retries. It can have timeouts, so you can allow a task to run for an hour and then kill it if it's not done by that point in time. You can have notifications if a task runs for too long, and then you can manually inspect it. I'm actually working on contributing some code to Airflow's SLA mechanisms to make it a little easier to have those kinds of alerts. Overall, it's a much more flexible system than cron, which just gives you either a success or a failure. Airflow has a lot of dependency controls. So for example, you can have a task that fires only if the previous task failed. So you can have a task that's like a recovery step or a task that adds a notification somewhere or updates a status page. Lots of capabilities like that. How do you deal with operators launching a compute instance with a long-running Python script? So how does Airflow know when that job is done? Well, in cases like that, we often write a custom operator. One of our examples of a long-running task like that is we run data ingestion servers that are one-off servers. So we have to start the server, install software on it, and provision it. And we use Ansible Tower for that provisioning. And then at the end, when it's fully provisioned, run a download script, run an ingest script, and at the end, tear down the instance once it's fully uploaded all of its results. So if we just had Airflow start that task and return, what would happen is we wouldn't have any good idea of when that task was done. So instead, we've written a custom operator that includes that waiting logic. It's able to start the job and then block and wait so that the other tasks downstream of it don't try and start before that data has been produced. Now, that's not always an option. I think it's generally pretty easy to write those operators, but sometimes there's reasons why you don't want to. And in cases like that, you can have a downstream task. So you first do a immediately returning start this somewhere task, and then you have a downstream task that explicitly waits for that to finish. So that might be waiting for a file to be produced in S3 by checking a particular S3 key. That's actually something that we do for our non-Airflow systems, things that we haven't managed to port yet. We still don't want to launch before those systems are done processing. So we wait for those systems to finish processing and have produced their data artifacts. So even if those systems are not controlled by Airflow, we can still wait on them in Airflow. It's a way to work in systems that you're still in the process of migrating. What are the challenges you ran into so far for Airflow? Well, one challenge that we've run into is managing Python versions, and in particular, managing the versions of Python libraries that are installed. Everything that runs in Airflow runs in the same Python environment. What that means is if one of your DAGs requires version 18 of pandas and the other one requires version 19 of pandas, that's actually going to be a conflict. So Airflow doesn't handle this particular use case very well. This is actually one of the reasons we've switched to using Docker containers for a lot of this, because that means each job that we run can have a totally isolated environment, and it can even run non-Python scripts. You can run whatever you want inside of a Docker container. So that's been really great for us, is breaking out and having Airflow execute less code and having Docker execute more code. But that's definitely been a challenge for us that we've run into. I think I have time for one more question, or yeah. I got another question about how do we actually version control our Airflow DAGs or manage a large amount of them. So for version controlling the DAGs, we have a DAG repository that's separate from the infrastructure code for deploying Airflow. So it's sort of like we have one set of code that deploys the cluster, and we have a second set of code that stores all of the DAGs and containers and data definitions that we need to be able to run a DAG. So we don't have hundreds of DAGs. We have a lot of tasks, but instead of having a lot of small DAGs, we have a handful of much more complex DAGs because we're really interested in the data dependencies. I know that Airflow can scale out to that. Airbnb does actually have hundreds or even thousands of individual DAGs. But in general, the approach for version control is pretty simple. We don't install it as a Python module or anything. It's actually just a version controlled Git repository of DAG files on the file system. And we use Git to synchronize that. So from the time that we push a new DAG commit to the DAG repository to the time it shows up on the Airflow server is something like 2 minutes or less, and it will automatically restart and integrate the new DAGs at that point. So it can be a very fast deployment process that way. I've heard that other people will do this by baking the DAGs into Docker containers. We don't run the Airflow servers themselves inside of Docker right now, so that's not an option for us, but that's probably something we'll look into in the future.
All right, so I think that's the end of the questions for now. If you do have a question that we didn't get to, or you think of something later and you want to know the answer, you can email it to us at events@quantopian.com, and we will make sure James gets to take a look at it. I want to thank James for a great presentation, and thank you everyone for joining, and we'll see you next time.
Thank you all.